Welcome to today's chemistry lecture. Today we are going to discuss our new chapter, which is reaction kinetics. In today's lecture we will study about the reaction kinetics, first concept, Clayen theory of reaction rate, and also the factors that depends on effective Clayen theory, which are number of particles per unit volume, the frequency of Clayens, the kinetic energy of the particles, and activation energy. In first, let's see what is reaction kinetics. So, introduction to reaction kinetics. Definition of rate of reaction: the speed at which a chemical reaction takes place. What is practical importance is that chemical reactions are only useful to us when they occur at a responsible and manageable rate. Goal of kinetics: to understand factors that govern reactions rate, which help us learn how reactions occur at the molecular level. So the Clayen theory is depend on reaction kinetics. Let's start to study Clayen theory. What is Clayen theory? The Clayen theory explains how reactant particles react to form the products. So let's see core concept of Clayen theory. The Clayen requirement: a reaction takes place only when participating particles such as atoms, molecules, or ions physically collide with one another. So what's effective versus ineffective Clayens? If the majority of Clayens reactant particles simply bounce back without any change, only a very small fraction of Clayens lead to formation of products. Clayens that successfully lead to a chemical reaction are called effective Clayen. Determining the rate: the overall rate of change of reaction directly depends upon the number of its effective Clayen. So this is very important that the Clayen theory is tell about the rate of reaction because it is directly depend upon the number of effective Clayens of the reaction. Let's see the key factors that govern the effective Clayen. First, the number of particles per unit. So, high concentration of reactant means there are more molecules present in a given space. The larger the number of particles per unit volume, the higher the total number of Clayens between them, which increase the possibility of effective Clayens. That means the effectiveness of Clayen directly depend upon the concentration of the reaction. As the reaction's concentration high, the possibility of Clayen will be high too. The more will be the reactant, then the product will be also more because possibility of Clayen will be effective and more. The second key factor is the frequency of Clayens. Point 1. An increase in number of Clayens occurring per second frequency directly increases the number of successful effective Clayens. Temperature effect: at higher temperature, the velocities, speed of molecules increase, causing them to collide more frequently. So it's also directly proportional to the Clayens because if we increase the frequency, the Clayen will be the increase and the result will be the more effective and we will get our product in a very short period of time. The third factor is the kinetic energy of the particles. According to the kinetic theory of particles, all matter is composed of tiny, constantly moving particles, and this motion is powered by their kinetic energy. Raising the temperature increases the kinetic energy of the particles, causing them to engage in faster, more vigorous motion. Fast moving particles have a much higher chance of colliding with one another. So, kinetic energy is also directly proportional to the effectiveness of the Clayian theory, because if we increase the kinetic energy of the particles, they will be collide more frequently and product will be produced. The fourth and the last factor is activation energy. First is colliding particle will only result in an effective collision if they possess sufficient energy to break the chemical bond present in the reactant molecules. So, for breaking the molecules, reaction must have sufficient energy. What is the definition of activation energy? The minimum energy required to start a chemical reaction is called activation energy. Energy distribution. At any given temperature, most reactant molecules only possesses average energy. Only a small fraction of total molecules have enough energy to exceed the activation energy barrier and undergo a chemical reaction. Energy conversion during collision. As reactant particles approach each other to collide, they slow down the kinetic energy they possesses it converted it into potential energy. Here comes the path of the reaction, as you can see in the diagram. If colliding particle possesses the required activation energy, they reach a transition high energy state at the peak of the curve. After reaching this high energy state, the reactants convert into stable product and the potential energy of the system falls back down. Here comes our quick checks. First question is, how will you increase the frequency of clean? As we read recently, by increasing the temperature, which increase molecular velocity, or by increasing the concentration number of particles per unit, we can increase the frequency of collisions. Second question is, what happens to the reactant particle after collision? If the collision is ineffective, they simply bounce back without any change. If they possess sufficient activation energy, they reach a high energy state and are converted into stable product as the potential energy of the system drops. So, today's lecture is complete. Hopefully, you can understand every concept that explains step by step and point by point. Thank you, everyone.